Binomial probabilities. Well, binomial, because of the word bi, means that there's two. There are two possible outcomes. They're called success and failure. You can make it a success and failure about just about anything. You take my name, Greg. Where's the success? Where's the failure? Well, all the people that have the name Greg, those are successes. Everybody that doesn't have the name Greg, failures. So it's not necessarily that there's some inherent good thing about successes and bad things about failures. It's just you're categorizing the yeses and the nos, the trues, the falses, the successes, the failures. But in this class, we call them success and failure. So two possible outcomes. So you're going to be given a probability. It's going to say something like, hey, did you know the fact that 46% of Americans drink Pepsi, or something like that. So you're going to be given some type of probability of a success. Well, if it was 46% that do drink Pepsi, then if you subtract from 100%, you can figure out the failure rate, or those that don't drink Pepsi. So for example, there's a 3% chance it will rain today. So success, it will rain today. 3% chance, or in binomial probabilities, we call that p equals 0.03. Failure, it will not rain. What are the chances of that? 97%. And failure, we use Q for failure. Okay, then the idea is, now suppose you look at the next 7 days. So based on this information of 3% chance, suppose that applied for the whole week, then what's the probability that it rains on exactly 2 days? That's where we're headed, but we've got a little bit of work to get there. So well, since this is a new situation, we do have some new notation. So as I said, a lowercase p, probability of a success. Lowercase q is probability of a failure. Since we're working with decimals, it's going to be 1 minus p that gives you the q. And then they will say something like, okay, over the next 7 days, so that's going to be the n, we want to know what's the probability it will rain for 2 days. So then that would be x equals 2. And then finally, when we calculate the probability, that's going to be capital P. On to another example. It's a fact that 80% of my Math 13 students pass the class. Suppose that you randomly chose 4 of those students. Find the probability 3 out of the 4 are going to pass the class. So there's an 80% chance for success, and I'm going to have 3 successes. 20% chance for a student not to pass, and we're going to have 1 of those. So we could multiply. So as you can see here, we've got a success, and a success, and a failure. And since the word and is in there, we are multiplying. Now, the only problem with this is this one puts the 0.20 as the last person. But who's to say it was the 4th person that was the one that did not pass the class? So what we have to do is consider all the cases. Maybe the person that did not pass was the 4th one, maybe it was the 3rd one, maybe it was the 2nd one, or maybe it was the 1st one. So there's really 4 cases where we have to multiply these numbers. So in other words, we have 4 cases where you've taken 0.80, multiplied it 3 times, and 0.20 and multiplied it once. Well, as I've mentioned before, it's lots of fun to list out all the cases, but it's better to have an easier way. Oh, by the way, the answer is 41%. What's more important to me is, where does that 4 come from? And it comes from combinations. And it's basically saying, out of the 4 places, I need to choose where to put that 1.20. So out of the 4 places, so out of these 4 places, I need to choose one of them to be the 0.20. Once you've chosen one of them to be the 0.20, so like here, I've chosen the 4th one to be the 0.20, then I know what the other ones have to be. Once I've chosen that this is going to be the 0.20, then I know the other ones have to be 0.80. So that's what this part is doing. So that we don't have to list all of the cases, we're going to be using combinations. So finally, what we have right here, what we've developed, is called the binomial formula. So that 4 in front, that comes from combinations. Then you take the chances of success and raise it to however many successes you want. Then this is the chances of a failure, and this is how many failures we're going to have. All right, now let's do an example from top to bottom. So I read this fact somewhere on the internet, so I'm not sure how true it is, but Google said it was true. Anyway, 84% of high school students admit to cheating at least once. Suppose you've got 20, so that's going to be n equals 20. Find the probability x equals 17 have cheated at least once. So first, you should write down the given information, p. So in this case, it's considered success if someone admits to cheating. Like I said, there's no real reason for calling it success. Anyway, then q is going to be 1 minus that. So in other words, 84% admit to cheating, 16% don't admit it. Then we've got 20 people. Find the probability that x equals 17. And we use the binomial formula. So it goes the n and then the x. Then here's the p, 0.84. Raise it to the x. And then when you subtract these two, if you're going to have 17 people that admitted to cheating, that leaves 3 that don't admit to cheating. And so you put that into a calculator and it'll tell you 24.1%. But now I'm going to show you how to use the calculator. It has the binomial formula programmed into it. So first of all, as you can see where my chubby little finger is, it's over here where it's distributions. Since the distributions is blue, you'll have to put second. So you'll have to put second and then distributions. And then it should look like this, distributions, and then scroll down like so until you find the binomial probability distribution function. Now on the next screen, so once you scroll down to A, you hit enter. But on the next screen, there's two possibilities. One is it will just put these letters. So if you have an operating system that is a little bit older, also known as a little bit better, then it will just put this on the screen. And then right here, you would put the n is 20, comma, and then you would put the p is 0.84. Sorry, my writing is so sloppy with this. And then the x is 17. Put a parenthesis and hit enter. Or if you have a newer operating system, it's going to look like this. Put the trials, which is n, the p, 0.84, then the 17, and when you hit paste, it's going to do this exact thing that we did in the older type calculator. So it would then look like that. After you hit enter, then it tells you 24.1% is the answer. Okay, there's just one more type of example that we need to do for this section. So there's this multiple choice test. Each one has A, B, C, or D. In other words, 4 answers to choose from. 20 questions total, but suppose you didn't study at all and you have to guess on each and every question. What's the probability of getting at least a C? What's the probability of getting at least 17 questions right? So with this one, you're not told the percentage, but you are told that there are 4 answers to choose from. Well, if you're guessing, you've got a 1 in 4 chance, or in other words, P equals a 25% chance of getting it right. Then the chances of getting it wrong, well, that would be 3/4. N equals 20, and then the difference for this one is it's saying at least 15. So that's x bigger than or equal to. And with these, this is the kind where we need to do 1 minus the opposite. You actually don't have to, but it is easier to do it this way. Because otherwise, if you don't do it this way, what you have to do is say, well, x equals 15, 16, 17, 18, 19, and 20. So that's 6 times you would have to do the binomial formula, and then you'd have to add all 6 of those answers. Yeah, that's what I thought. Let's do it this way. So you do 1 minus the opposite, And the opposite of at least 15 is that it's less than or equal to 14. So if it's not going past 15, then it's got to be 14 or below. Then this part is in the calculator. So just a moment ago when I showed you the calculator, we found the binomial PDF. Well, this one is the binomial CDF. And what it does is it adds up all the cases from 0 up to 14. And here's the answer. Now let me show you on the calculator. So you need to begin with that 1 minus, and then we need to go to the distributions. So as before, get the second and distributions. And this time scroll down to the binomial CDF. And then the same story as last time. You either have the operating system that has this with the trials, the p and the x value, or you have the one where you would just type it right here. And then when you hit enter, it would have the 1 minus binomial CDF. Just hit enter one more time to get the answer. And this is scientific notation saying move this decimal over to the left 6 places, which means that we have 1, 2, 3, 4, 5 zeros as placeholders, and then 3813. So this is saying the chances of getting a C by guessing are very, very, very small. So please study.